Okay, so here's a quick reminder review kind of description of why the answer to number 15 was different than all the other ones, why it needed that absolute value. Okay, so if we look at this, we're going to take the square root of 16. That's going to give us the 4. There's a negative on the outside, so we just bring that down. The square root of c to the 4th is how many groups of size 2 do we have in c to the 4th? That's c squared. And then how many groups of size 2 do we have in d squared? That's just d. So we would think that would be the answer, but if we look at what happens when we take the square root of 5 times 5, that just gives us 5. But if we take the square root of negative 5 times negative 5, we don't get negative 5 back, we get 5 back because we're taking the square root of 25, and we're always talking about the positive square root, so that gives us the 5. If we replace the negative 5 down here with a d, and then we have the same thing when we take the square root of that, so we're taking the square root of d squared, we won't get the negative 5 back. We won't get d itself back. D started out as negative 5, but that's not what we're going to get back. We're going to get back the positive value. We're going to get back the absolute value of d. Okay, a couple different examples just to remind you of where you're going to need. Here's a decision tree to decide when to use the absolute value. Is the root even or odd? For that, you're going to look at the index number. Is it a square root, cube root, whatever? If it's a cube root, you're fine. If it's fifth root, you're fine. If it is an even root, 4th, 6th, 8th, you need to go look at the next thing. Look at what you got in your answer factor, the part outside the radical sign. If that's even, you're okay, because anything to an even power comes out positive. So we wanted a positive answer, we got a positive answer. But if it's an odd thing, odd exponent outside the radical, we need to think further. This part we'll talk about more tomorrow, but look at the exponent on that factor inside the radical sign. If there isn't one inside, or if the one inside, what's left inside is even, you're going to need an absolute value. If what's left inside is odd, you will not need the absolute value. Let me give you an example for that. And this is what we will be looking at tomorrow. Let's say you're going to be taking the 4th root of a to the 8th, b to the 12th, and c to the 19th. That's going to give you an a squared. No need for an absolute value because that was an even index, but the exponent on the answer factor was even, so we're good. It will always be positive. The b is a b to the 3rd. That will require an absolute value sign because that's telling us here the exponent on the answer factor was odd, so we needed the absolute value. And then we're going to look at the c. We end up with a c to, what did I say, 19? So c to, oops, that's not a good example. Let me go back and change this to 21. Then this will be c to the 5th. You'd think that that would need an absolute value, but it doesn't because we also are going to have one left inside. And so we'll talk more about this last part tomorrow. Okay, so in this example here, it's a 5th root, so we don't care. We're never going to have the absolute value. The 5th root of a positive number is positive, the 5th root of a negative number is negative, and we're just good to go. If we look at this example, we're taking an even root. Remember, it's a square root in here, so it's an even root. Square root of 100 is 10. Square root of x squared is x. Square root of y to the 4th is y squared. Square root of z to the 6th is z to the 3rd. We need absolute value bars around the x and around the z to the 3rd because if we're following the rules, it's an even root and we have an odd power in our answer, right here. So we need to have absolute value bars on. If you think about being negative, we could have started with a negative value for the x, started here with a negative value, but when we take the square root of it, it's going to come out to be a positive number. So we have to make it be positive with those absolute value bars. Same thing with the z. If we'd started out with a -2 and took it to the 6th power, it would have come out positive. Even root of a positive number is positive. We want this to be positive, but unless we put the absolute value bars on it, it won't be positive. We don't need to worry about that with the y's, remember, because y squared is always positive no matter what. If we look at this example, square root of 16, 4, no problem. Square root of a to the 10th is a to the 5th, but a could have started out to be a negative number. Taking it to the 10th power made it positive, took the square root, still positive, but over here, if a is a negative number, a to the 5th will be negative. We need to make it be positive. Same thing here with the w. We don't need it with the v because v squared is always positive, but the w, we will need it to make it be positive because w could have started out as a negative number and become positive over in here. If we go back to the rule, it's an even root. Answer is an odd power. Even root, answer is an odd power, so we need the absolute value. Here, we don't need it because the x squared comes out to be an even power. If we go back and look at the summary of those rules,